Yeah, g'day, it's Charlie ZL2CTM. Well, I thought I'd just do a video tonight just to do a quick update on where I'm at with the radio and the next steps. So what I've done over the last couple of days of our lockdown here in New Zealand is just to spend a little bit of time configuring the radio and cleaning it up a little bit, getting ready to start on the transmitter. So just to sort of go through very basically now, I've got a couple of relays up here. So they are providing the antenna switchover relay. So that left hand one there is the antenna switchover relay, which will go between obviously the receive side here and what will be the transmitter coming up here. We have another relay over here which is switching the 12 volts between the receive circuitry and the transmit circuitry, and then there's a 5 volt regulator there which is providing the 5 volts around for the Arduino and the display in SI5351. On the receive side, no real change here. We've got the RF coming through the bandpass filter. I have added down here just a little 3904 RF amplifier with variable output there, just to provide a little bit of a boost before going into that first mixer. No changes to the IF stages. They're still exactly the same with the first IF, the crystal filter, albeit the crystal filter now has just been taken off that other board and reconfigured to be a little bit more compact into that second IF amp and into our audio frequency amplifier. Just down here, and I'll go through this in a sec, I've added in a small 3-stage RC low pass filter, which is just filtering a 700 Hz tone that's coming out of the Arduino to provide a tuning function. Right, so let's just have a quick look at the RF amplifier here, and then I'll double back around and just talk about what I did from a tuning point of view, and then getting ready for the transmit side of the house. So the amplifier itself is very straightforward, pretty well the same that I've done in other times. A 2N3904. In this particular case, what I've just elected to do, just a little bit different, is in the collector here, rather than having a transformer to transform that 50 ohms back up to 200 ohms for the collector, I've just elected to use an RFC, which is 10 turns on an FT37-43. And then just dump all of that RF across a 10k ohm trim pot, or variable pot more the point, which allows me just to sort of vary the output of that before it feeds into the that first mixer. The maths itself, I'm not going to go into it, exactly the same as we've seen in the past, just setting the emitter voltage to the 10th of 12 volts, and the other two figures for the R2 and the R1 calculations are exactly the same as we've had before. And I'll put all this up on the blog. For the input, what I've elected to do now, the input works out to be 84 ohms. I've crossed this out because this was something I was playing around with, but I've elected not to do it in the end. So our RN is our R1 resistor up here, in parallel with R2, which is the 3.3K, in parallel with our beta AC. So 300 megahertz divided by 3.5 gigahertz is 85.7, multiplied by little re, so 26, divided by our emitter quiescent current, which I set to 10 milliamps for this amp, plus R. It's fully bypassed, so that R is equal to 0. Comes at 84 ohms, which I've said is pretty close to 50, so I've just had this, from an input stage point of view, just plugged straight into the bandpass filter over here, and I'll get into it later on. That low pass filter, which is filtering the square wave, the 700 Hertz square wave, which is coming out of the Arduino from a tuning point of view. Again, I'll talk to that in a sec. 3 stages of RC low pass filter. We know that our minus 3 dB point, so on the bend, on the knee, so to speak, of the pass band, that point there, the minus 3 dB point, is 1 over 2 pi RC. So I've just used, for values there, a 1k ohm resistor and a 220 nanofarad capacitor. Comes out at 723 Hertz, which is about right. I'm quite happy that to be a little bit of attenuation at 723 Hz, because my main aim was to really start to knock back the second harmonic onwards that I wanted to have a little bit further down in the stop band. Right, so let me just zoom back out a bit here. So why I've introduced that 700 Hz tone is, I want to listen to CW. The tone I want to hear coming out of the speaker is 700 Hz. That's the frequency I want to hear the tone. But I want to tune the radio in such a way that when I hear 700 Hz coming out of the speaker and I go to transmit, I want the transmit frequency to be spot on the actual frequency that's being transmitted by the other station. So what I've done here, and with the aid of the SIGGEN up here, I've got a 3.525 megahertz. I'm going to turn that on. So I'm now transmitting just a carrier wave on 3.525 megs. Down here I have 3.525 megs selected, and we can hear we have a 700 Hz tone coming through there. If I grab the speaker, of course, we get a bit more coupling, so very loosely coupled there, but that does turn out to be 700 Hz. So what I've also done there, so there's a little button down here on the side here which I can hit with my finger as I tune, and that introduces a 700 Hz tone into the signal. So if I was to tune this off by, say, a KC, and I was to push that little button, I'm now injecting a 700 Hz signal into the AF amplifier. So it's going through that tone here, and we'll look at the code in a sec. That 700 Hz tone there is a square wave here. Out here it's pretty close to a sine wave, and I've just feeding that into the output of that product detector, where it's now disappearing off into the audio frequency amplifier and through. So again, I push that button there, I tell the Arduino to output a 700 Hz square wave, gets converted to a sine wave and amplified. That's what we have here. Now, as I tune my input signal, you'll start to hear a beat frequency. Here it comes. So I'm just starting to get my input signal here. So this is 35247, so I'm 300 Hz off where I want to be. It's just now starting to come into the pass band of the crystal filter. Here it comes. I'll just slow it down again. I'll just change 10 Hz at a time. You can hear it coming down. And what I want to do is I want to have that received tone to be exactly the same as my tuning tone. And you can start to hear the beat frequency there, getting close. You can hear wah 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 wah, wah 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 wah. And there we are. So 3525, and the beat frequency is gone. If I go out the other side, we start to hear it come back again, come back down, disappears. I can now release my tune, and I'm now outputting on the radio a 700 Hz tone, which would be, if that was a Morse code signal, would be my my received Morse. Right. So let's assume that he's now finished transmitting, and it's my turn to transmit. What I have now done is I have, the way I'm doing this from a transmit point of view, and we'll look at the code, is when I key, I've got the Arduino sensing that it's being keyed, and I'm enabling clock 2 output. Now the clock 2 output I've got coming out is at the transmit frequency. So in this particular case, I've tuned in, I've zero beated him down to what my received 700 Hz. I'm zero beat. If I now key, I will transmit out of this orange wire here, which will eventually go through the transmit circuitry, a 3.525 megahertz signal. Now, what I've elected to do, in order to give myself some side tone so I can hear what I'm actually transmitting, I have left the receiver running. So later on, once I boost this right up, so at the moment there's a very low level signal coming out of this wire, which is being picked up by the receiver and is outputting a 700 Hz signal. Why? Because I'm spot on the received signal, and I'm transmitting on that same signal. So again, key down, we hear a 700 Hz tone coming through, and that's, like I say, my output of clock 2 being picked up by the radio, demodulated and sent out the speaker. Later on, once I amplify the signal here and it gets much larger in amplitude, I will have an added bit of circuitry over here that will just knock down the AF gain while I'm transmitting. So I just get a nice level of 700 Hz coming out from a side tone point of view. And the other thing too, so that's how I'm doing the transmit, and we'll look at the code in a sec. Also, once I go key down, the Arduino is sensing that the key is down, and it's outputting a logic level low, which is going to this relay, which is swapping over the antenna to transmit, and it's also outputting a low to this relay over here, which is toggling that one over, and you'll see the green lights come on when they're being activated. I've got semi-break in here, so on this particular radio I'm not going to use a manual transmit receive switch. So what happens is when I key down, a timer starts in the Arduino, and as I transmit, everything's all going very happily, and then when I key up, 1 second later, the timer times out, and those two low signals that return back to high, and the relays then toggle back to receive. And you'll see in the code too, from a specifications point of view, these two relays here have an on time of 10 milliseconds maximum. So it takes 10 milliseconds to go from, or the contacts to change from the normally open to the normally closed. Sorry, vice versa, the relay to actuate. So what I've done in the code, and you'll see that there, I've doubled that, added a little bit more, so there's a 25 millisecond delay from when I key down to allow the relays to swap over before this output here is actually enabled, which will then go through the amplifier, and off we go. And I must remember to talk about the amplifier. In fact, I'll just put that there, which will act as a big reminder to talk about that as we go. Right, so let's just have a quick look at the code, and then I'll come back and have a talk about that. So, again, apologies for just zooming up on the screen. This video has been taken at 7:20, so hopefully it should be quite clear what's going on here. So we have here the main loop of the program, and the first part of the loop is this digital read key. So this is sensing the input to the Arduino is coming from my Morse code key, which is switching in a low. So when, let me just turn that volume down, when the key is up, the pull-up resistors are making that particular digital input high, but when I go key down, I provide an earth. So this if statement then becomes true. So if key down, I start the break-in timer, that's that 1 second timer we talked about before. I then digital write to both the antenna relay port and the power relay port a logic level low, which then makes those two relays actuate. And then I have a delay here for 25 milliseconds. I'm really sorry about those artifacts with the screen there. I don't think I can do much about that. Maybe that's a little bit better there. So like I say, the break-in timer starts, those two relays get actuated, there's a 25 millisecond delay there, just allow time for those relays to fully make before I enable clock 1. So there goes the clock 1 there, and a logic 0, say again a logic 1, which I'm saying you are now enabled, get ready to transmit. And then the very next command is send frequency. If we were to race down to the very bottom, that would basically tell the SI5351 and that send frequency function, which is down the bottom there, to actually output on clock level 1 the frequency that the radio is tuned to. Else, so this if statement here is if the key is down, do this. Else, in other words, the key is now up. I want to disable that output because if I was sending Morse code, when the key is up, I don't want to send a carrier, so I need to disable that output, hence that 0 there as opposed to a 1. And that's it. That's all that happens. Now of course with the key up, the break-in timer is still running, so these two relays here are still actuated because that 1 second timer is still running. We race through the loop a couple more times, and then each time it's checking for this. So if the current millis times, the current time in millis, minus the break-in timer, that's the one that we set back here, is greater than or equal to the break-in delay, which I've got set for 1 second, I want you then to program, I want you to return the antenna relays and the power relay back to where it was. So in other words, output a logic level high to those two relays and they de-energize. And that's it. I won't go through the rest of the code at this point in time, apart to say that this another little section down here of the for loop is that tune. I had that 700 hertz tone out. So if that momentary tune switch is down, in other words I'm pushing it, I send out a tone out the oscillator port, so it's just one of the digital ports, it outputs a square wave at 700 hertz. Else, in other words, that tune switch is not down, no tone, and that's it. So from a software point of view, that's just a little bit of additional code I've added in there to enable, so to speak, the additional hardware that's been added to the radio, a la the tuning 700 hertz filter here in the output, and the break-in relay, the break-in timer for the two relays with the side tone. Okay, right. So from a receive point of view, there's probably nothing else I'm going to do at this point in time. I'm quite happy with how that's performing, so I'm not going to do anything more on that. So now my attention is now going to shift to taking this output on transmit and amplifying it up to a useful RF level to eventually go back out that antenna on transmit. I had initially talked about early on when I was talking about this particular radio of doing a sorry about the reflection there, doing a class C amplifier. I've actually decided I'm going to go and have another play around with class E amplifiers, which I was playing with just before Christmas. So this is what I'm going to do here. I'm going to resurrect that class E amplifier I was playing around with. It's going to use just a stock standard off-the-shelf MOSFET. In this particular case, I'm going to try 510s and probably 540s in that. This one here is a 540. It's got quite a high level of input capacitance on the gate. So what I'm going to use one of these little chips here, which is a MOSFET driver. So that particular little device here is an MC34151, which is designed for high-speed switching of high or large capacitance loads. And it's a MOSFET driver. So the idea would be then that it's going to be triggered, so to speak. That's the wrong terminology, but I'll use it for now. From the output of the over here, the output of that SI5351, come through to here, condition it, so to speak, turn on the that MOSFET, and then we'll go from there from a Class E point of view. So that is the plan, but may need to have a pre-driver for that. I don't know, I haven't got there yet. Like I say, early days, and it's all about experimenting and playing and see what can be done. Okay, I think that pretty well covers what did I want to talk about. So let me just refresh my memory. We talked about the two relays there. We talked about the RF amplifier with the gain there. We talked about the tuning switch down here for tuning the radio in, or in other words zero beating, to make sure that when I go to transmit, I'll be transmitting exactly on the frequency that's coming in. We talked about that low pass filter there. So yeah, I think we've basically covered it all. So I'll say 73s at this point in time, and certainly with this whole COVID-19, really hope everybody stays safe. You know, keep washing those hands, keep that sort of social isolation. But on the flip side, when you are isolating yourself, you know, keep in touch with your neighbours, keep in touch with other hams, and yeah, keep on the ear and just make sure everybody's safe, because it is quite hard being locked away inside your house for such a long time. So yep, be safe, be kind, look after each other, and once I do some more playing around with the RF amplifier here, I'll put up another video. But like I say, everything's up on the blog, and we shall go from there. Okay, 73's all. Cheers.